Hey guys, this is just a quick video. We'll be considering our second case in pipe flow, which is turbulent flow in a rough pipe. This flow has the added element of roughness thrown into the mix. So this was the delta P equation we used for laminar flow. In laminar flow we got rid of roughness. Now we're considering roughness. Now I said to consider roughness as a similar concept to friction. The roughness of the pipe, if we look at a close-up of the pipe wall, say if that's the pipe wall and the fluid is on this side here, the pipe wall is actually quite irregular. So the roughness is a measure of that irregularity. So the greater the roughness, the more frictional type force is wasted at the pipe wall. So that's the additional complication we're going to consider in turbulent flow, and we're going to be using this equation, which through dimensional analysis, the same process we went through with laminar flow, we can reduce it to a function, but this time it's going to have two variables in the function to the friction factor, Darcy friction factor function. So we're going to have L on D times F epsilon on D RE half rho V squared. So for laminar flow we didn't have this term here. Now we got to consider roughness. That makes things quite a bit more complicated. RE is not given as 64 on RE for this case, for turbulent flow. Instead it follows a complicated curve that can only be graphed experimentally due to the effects of roughness. So our Darcy friction factor F is actually found by finding RE and roughness and looking up the corresponding friction factor value in a chart called the Moody diagram. So that's this one here. So the method associated with turbulent flow is quite a bit different to laminar flow, mostly because it relies on two variables as opposed to one. So questions will often involve an iterative process to find the solution, which really is a pain in the ass. So careful of that. But back to the Moody diagram, I'll just point out a few things on it that you should know. Now this is a log-log graph. So the scales on the vertical and horizontal axes are log scales. Reynolds number is on the bottom. That's Reynolds number down here. And that ranges from just under 1,000 to up to 100 million. And friction factor on the vertical scale ranges from 0 to 0.1. Now each of these curves in the diagram